Before we start solving equations that are very complex, I will just do a quick review of what we learned in the previous video about solving trigonometric simple equations. So for example, if you have to find theta when sine theta is equal to square root of 3 over 2, you have to imagine your trig circle. So think about your trig circle. And sine is your y value. So when is the y value equal to square root of 3 over 2? If you don't remember the value on your calculator, if you do square root of 3 over 2, you get about 0.89 or something like that. So that's, remember that on the top here, it's 1. So that's about where you should be. So the two angles that you have, there's one here. So the first angle here is theta, and the other one would be pi, which is here, minus theta, and that would give you your second angle here. And because this one is one of the angle we know, then you should know that theta is equal to pi over 3, and the second one is 2 pi over 3. Now if you add to do cosine, cosine is going to be the x value of your angle, of your trigonometric point. So for example, if you want to find when cos theta is equal to negative 1/2, think about your trig circle. Negative 1/2, remember this here is negative 1, so negative 1/2 is around here. So when is this angle equal to this? So if you remember your values, the first angle here, this is 2 pi over 3. And to figure out the other one down here, because it's the same on the top and on the bottom, to figure out you would do 2 pi, which is the whole circle, 2 pi minus your angle theta. So here, if you count by pi over 3, that was 2 pi over 3. Here would be 3 pi over 3, and this one would be 4 pi over 3. So your two angles are 2 pi over 3 and 4 pi over 3. So the first thing I wanted to do was to look at the real life problem. So I used the problem from CSC Vision Book 2, Activity 1, page 114. They're showing you the region's weather forecast, and they're giving you also the equation here at the bottom. And my question is, in these 2 days, when was the temperature equal to 2 degrees Celsius? So you can see 2 is around here. So when is it that the temperature is equal to 2 degrees Celsius? So on this case, when we look at the graph, it's quite easy to look at the solutions, but it's not going to be always like that. So I'm going to do it with you algebraically so you can be able to figure it out in any situation. So we have our rule, which is 2 sine of pi over 12 x minus 6 plus 1. We want this to be equal to 2. So the first thing we're going to do is isolate our sine part. So I'm just going to show you. So we're going to need to get rid of the plus 1 here. So to get rid of plus 1, we do the same thing on both sides. We're going to do minus 1 on both sides. So now we're left with 2 sine of pi over 12 x minus 6, and that now is equal to 1. And then there's a 2 at the beginning here, so to get rid of that 2 here, we need to divide by 2 on both sides. So we are left with our equation in sine pi over 12 x minus 6 is equal to 1/2. So this is where you have to remember now. I want to figure out sine of which angle here, this is my angle, is equal to 1/2. So you have to remember your trig circle. Sine is your y value. So when is this equal to 1/2? So we have two values. We have the first one here, which is pi over 6. And we also have this one here, which is 5 pi over 6. So that means that our angle here has two different possible values. So we're going to write it like this. So pi over 12 x minus 6 can be equal to pi over 6, or it can be equal to 5 pi over 6. And after that, you just have to isolate to figure out your x. Because there's some fractions involved, I know some of you might find it a little tricky. So the first thing here, you need to get rid of that, and it is multiply. So that means on the other side, you need to divide. Now, if you remember, when we divide a fraction, it's the same as multiplying by the reciprocal. So if you have pi over 6 and you want to divide by pi over 12, you can multiply by the reciprocal. So you can multiply by 12 over pi. And here, because you have a pi on the top and on the bottom, you can simplify. And after that, you're left with 12 over 6, which is 2. So you have x minus 6 is equal to 2. And to get rid of your 6, you would plus 6 on the other side. So you find that your x is equal to 8. So that would be your first solution. If you go back on your graph, you can see that it's correct. We got our first solution here. We're going to do the same process on the other side. So x minus 6 will be equal to 5 pi over 6. And when we divide by pi over 12, we can multiply by the reciprocal. So 12 over pi. And again, simplify. So we're going to be left with 5 times 12, which is 60 divided by 6. So x minus 6 is equal to 10. And if we move the minus 6 on the other side, we're going to get that x is equal to 16. If you go check in your graph, that is exactly the second point here. Now, we only find two solutions. What about the other solutions up here? So if you remember, this is a periodic function, so we need to find the period. How do we find the period? So the easiest way I suggest is you take the top point here. What is the period between this point and this point? So between 36 and 12, the period is equal to 24. So I can use my first point here, who was 8, and if I add the period plus 24, I can figure out my second point, which is 32. And you can do the same thing with your 16. Here I add 16 plus 24. I can find my other point here. So what I did is I used Desmos to check my solution. So you can find all the points that are equal to 2. So now I'll show you 5 different examples of problems where you would have to solve trigonometric equations. So as you're watching the video, I suggest that you try it on your own, and then after you can watch the video to make sure you're on the right track. So here are the steps that I'm going to be using for each of those equations. So first, we're going to isolate sine of x or cosine or tangent. And then we're going to find the possible measures using the trig circle. And then we're going to be able to form our equations and then solve our equations. And then at the end, we need to find all the solutions. So we're going to need to find our period and then add or remove the period to find all the solutions. So let's look at example number 1. I used number 1A from page 118 in your book. The question is, determine the solution set for this equation if x is between minus 3 pi and 3 pi. So this is not only going to be in the first circle, in the first turn, we're going to need to find a little bit more than that. So let's look at the first step. So for first step, we need to isolate this part here. So that means we need to get rid of the 2 that is on the left. So that means we're going to have sine of 2x minus pi over 6 is equal to square root of 3 over 2. Then we can find all the solutions. So what I did here, I divided by 2 on the left and on the right. So look at your circle. Sine is the y value. So when is it equal to square root of 3 over 2? It's around here. And so that means our angle can be equal to pi over 3, or here 2 pi over 3. So step 3 suggests to form two equations. So I can write down that my angle, which is this part here, my angle 2x minus pi over 6 can be equal to pi over 3, or, so that's my first equation, or 2x minus pi over 6 can be equal to, sorry for my 6, 2 pi over 3. And then using these two equations, in step number 4, we're going to solve for each. So first step, we're going to start by getting rid of the 2. So we divide by 2. And here, if we want to divide by 2, when you divide by 2, this is 2 over 1. So remember that when you divide, you multiply by the reciprocal. So now we're going to be left with x minus pi over 6 is equal to pi over 3. And we multiply by 1/2. And remember, when you multiply top with top, bottom with bottom, so we are left with pi over 6. So now we have x minus pi over 6 is equal to pi over 6. How do we get rid of minus pi over 6 here? I'm going to come back to this. To get rid of this minus pi over 6, we need to go on the other side and add plus pi over 6. So what is pi over 6 plus pi over 6? Our first solution is equal to 2 pi over 6. 2 pi over 6 we can simplify by dividing by 2 up and down, and we get pi over 3. So we do the same thing on the other side. So we're going to have x minus pi over 6 is equal to 2 pi over 3. When you divide by 2, you multiply by 1/2. So we are left with 2 pi over 6. Now we have x minus pi over 6 is equal to 2 pi over 6. And to get rid of our minus pi over 6, we move it to the other side, and it's going to be plus pi over 6. So now we have 3 pi over 6, and that can be simplified. If we divide by 3 up and down, we should get pi over 2. This is our second solution, pi over 2. Now we have to find all the solutions, because they're asking us to go from minus 3 pi to 3 pi. So right now, the two solutions that we found were in the first quadrant, pi over 3 and pi over 2, right? So we need to find what are the other solutions. So if we start with our first one, well, let me sketch just a little sketch here of our function. So it's a sinusoidal function, so it looks like this, right? So right now what we did is we found two solutions. We found, let's say, this pi over 3 and pi over 2. Now to find the other solutions, we need to add the period or to remove the period until we have all the solution from minus 3 pi to 3 pi. So if I'm starting here at my x1, and then I want to find actually the next one, I'm going to call it x3. I'm going to start pi over 3 plus, what is my period? Well, let's go back to check our equation. Here in my equation, to find the period, you need to do 2 pi over b, and here the b is 2. So 2 pi over 2. My period in this problem is pi. So I'm going to start with pi over 3, and I'm going to add my period, which is pi. Now remember, when you want to add fractions, they have to be on the same denominator. So this one is over 1. I'm going to need to times by 3 at the bottom, times by 3 at the top. So I'm going to have pi over 3 plus 3 pi over 3. My second point will be 4 pi over 3. Am I still in my interval? If you want, this here is over 1, right? So if we want to put it over 3, we need to times by 3 up and down. So this is minus 9 pi over 3, and this would be 9 pi over 3, right? So this is my interval. So if I am at 4 pi over 3, can I go to the next one? Yes, I can find the next one. So I'm going to start with at 4 pi over 3 and add my period, which is pi. And remember, this is the same as 3 pi over 3. So the next one would be 7 pi over 3. If I add another 3 pi, if I start at 7 pi over 3 and then I add 3 pi over 3, I'm going to be at 10 pi over 3. And this is more than my interval, because my interval here stops at 9 pi over 3. So I'm not going to take this as an answer. So now what I did is I added the period. Now what I have to do is remove the period, right? So I'm going to start at my pi over 3. I was at pi over 3. I'm going to remove my period. Okay, so wait, so I'm at x5, pi over 3, and I'm going to remove 3 pi over 3. And I'm going to get minus 2 pi over 3. Is this in my interval? Yes, because I have to keep going until I reach negative pi over 3. And what I just did right now is I started with this point. Now you're going to have to do all of that again with the second point, with pi over 2. So this is a long question. It takes a little while. When you are done, all of your answer, you put them in order from small to big, and this is what you should get. Let's look at the second example. Now this one is using tangent. So find the zeros of the function f of x is equal to square root of 3 tangent of pi x minus 1. So what does it mean to find the zero? It means that you need to find when square root of 3 tangent of pi x minus 1 is equal to 0. So step 1, you need to isolate your tangent. So tangent is this part here. So how do you isolate? You need to get rid of the 1 and the 3. So we're going to send it on the other side. So the 1 is going to be plus 1, and here we're going to divide by square root of 3. So we end up with this tangent of pi x is equal to 1 over square root of 3. Now, if you remember, when we have a square root at the bottom, we could rationalize and we could multiply by square root of 3 at the bottom and at the top, and we would get this. Now you need to remember your trig circle. So think about your trig circle. And you need to find tangent. You need to remember also tangent of theta is equal to sine over cosine. That means that it's your y coordinate over your x coordinate that needs to give you square root of 3 over 3. So you need to think about, you're going to need something like 1/2 a square root of 3 over 2. So by looking at the different points, you're going to figure out that the point that works is it's at pi over 6 here, because at pi over 6, the coordinate is square root of 3 over 2 and 1/2. And if you do 1/2 divided by square root of 3 over 2, when you divide, you multiply by the reciprocal. So you would get 1 over square root of 3. So that means that your angle here, your angle is equal to pi over 6. So you could write a new equation, pi x is equal to pi over 6. And then you need to solve for x. You need to find x. So you need to divide by pi. If you divide by pi, you're gonna have pi over 6 divide by pi over 1. This is pi over 1, so you can multiply by 1 over pi. And you see that your pi will simplify, so you get your x is equal to 1 over 6. Now, this is just one solution. What are all the other solutions? Remember that what is the period for tangent? If you remember, the period for tangent is pi usually, but if there's a b, then you need to calculate. So the period is going to be pi over b, and in this case, b is pi. So the period here is 1. So to find all the solutions, then you know that x will belong to this. It's going to be 1 over 6 plus 1 k. K is the number of turns that you're going to need to find all your solution. So k has to be part of the integer. K is going to be like 1 turn, 2 turns, 3 turns, or in the negative also. So that would be the way to write down all your solutions. It would be 1/6 plus 1k, where k belongs to the integers, all the positive and negative integers. It cannot be like 1.2. It has to be a whole number. Let's look at example number 3. So now I suggest you pause the video, try to figure it out, and then after you can come back to check if you got the right answer. If you're not sure, you can follow with me. So find the zeros of this function. So what does it mean really? It means that you need to take your function and put it equal to 0. Step 1, you need to isolate your sign. So you need to isolate this. So what do you do with your minus 30? Send it on the other side. And then your minus 60, you're going to divide by minus 60 here after. So you end up with sine theta is equal to 30 over negative 60. You can simplify that. Oh, sorry, yeah, okay. So it's going to be negative 1/2. So if you remember in your trig circle, negative 1/2 is your y value. So it's going to be around here. What are the two angles here? This is pi, so remember that's 6 pi. So the next one would be 7 pi over 6. 7, 8, 9, 10, 11. The other one would be 11 pi over 6. And remember that a full turn is 2 pi, and 2 pi is 12 pi over 6. So we're good. So our two values are 7 pi over 6 and 11 pi over 6. So that means that theta is equal to 7 pi over 6 or 11 pi over 6. They ask you to find it over one rotation, so we are done. We don't have to do plus 1 period, minus 1 period. So that one was a little easier. Example number 4, find the zeros of the function. So again, you need to put that equal to 0. So you're going to start with this 2 cosine of x minus square root of 3 equals 0. So the first step consists of isolating this. So you need to get rid of everything that's around. So you should isolate by getting square root of 3 over 2. Then you think of your circle. Think about your trig circle. When is your x value equal to square root of 3 over 2? It would be around here. So this angle is your pi over 6. And the other one at the bottom here would be 11 pi over 6. That means that your angle here, x is either equal to pi over 6 or 11 pi over 6. Now, these are just two answers. You need to find all of the answers. So when you write down, you would write it like this. Pi over 6 plus, now what is the period here? It's a regular cosine, so the period is our regular 2 pi. So pi over 6 plus 2 pi k, that's the first solution. The other one is 11 pi over 6 plus 2 pi k, and that is when k belongs to integers. So that's the way to write down all your zeros for this function. And the last example, they're just asking you to solve, but you know that with the definition of the zero, really what they want you to find is all of the solutions over this function. So first step, you need to isolate your sign. So get rid of the 1 and the 2. So you know that sine 3x has to equal 1/2. That means you need to find what are the angles here that are possible for this. So think about your trig circle. Sine is your your y value. So when is this equal to 1/2? You have two possible solutions. There's one here, pi over 6, or this one, 5 pi over 6. So that means that your 3x can be two things. 3x can be pi over 6, or 3x can be 5 pi over 6. If you want to isolate your pi here, you need to divide by 3. Dividing by 3 here, this is 3 over 1, so you can multiply by the reciprocal, which is 1/3, so you get pi over 18. And on the other one, you're going to get 5 pi over 18. Now these are just two solutions. You need to find all the solutions. So remember, you need to find your period. So to find the period is 2 pi over b. b in this case is 3. So that means your period is 2 pi over 3. So to find all your solutions, you're going to write that your x belong to this solution set. Pi over 18 plus 2 pi over 3 k, k being the number of turns, positive or negative. And your second solution is 5 pi over 18 plus 2 pi over 3 k. And k needs to belong to the integers, because you want to have a complete number of turns, a full number of turns, positive or negative. So now you can just practice with any equations that you want, and you can always use Desmos to check your solutions and make sure that you're correct. Have fun!